Power. Incandescent lamps are nearly pure resistive loads with a power factor of 1. Unlike discharge lamps or LED lamps, the power consumed is equal to the apparent power in the circuit. Incandescent light bulbs are usually marketed according to the electrical power consumed. This depends mainly on the operating resistance of the filament. For two bulbs of the same voltage and type, the higher powered bulb gives more light. The table shows the approximate typical output, in lumens, of standard 120 volt incandescent light bulbs at various powers. Light output of similar 230 V bulbs is slightly less. The lower current, higher voltage, filament is thinner and has to be operated at a slightly lower temperature for the same life expectancy, which reduces energy efficiency. 126. The lumen values for soft white bulbs will generally be slightly lower than for clear bulbs at the same power. Current and resistance. The resistance of the filament is temperature dependent. The cold resistance of tungsten filament lamps is about 1/15 the resistance when operating. For example, a 100 watt, 120 volt lamp has a resistance of 144 ohms when lit, but the cold resistance is much lower, about 9.5 ohms. 70. B. Since incandescent lamps are resistive loads, simple phase control triac dimmers can be used to control brightness. Electrical contacts may carry a T rating symbol indicating that they are designed to control circuits with the high inrush current characteristic of tungsten lamps. For a 100 watt, 120 volt general service lamp, the current stabilizes in about 0.10 seconds, and the lamp reaches 90% of its full brightness after about 0.13 seconds. 127. Physical characteristics. Safety. The filament in a tungsten light bulb is not easy to break when the bulb is cold, but filaments are more vulnerable when they are hot because the incandescent metal is less rigid. An impact on the outside of the bulb may cause the filament to break or experience a surge in electric current that causes part of it to melt or vaporize. In most modern incandescent bulbs, part of the wire inside the bulb acts like a fuse. If a broken filament produces an electrical short inside the bulb, the fusible section of wire will melt and cut the current off to prevent damage to the supply lines. A hot glass bulb may fracture on contact with cold objects. When the glass envelope breaks, the bulb implodes, exposing the filament to ambient air. The air then usually destroys the hot filament through oxidation. Bulb shapes. Bulb shape and size designations are given in national standards. Some designations are one or more letters followed by one or more numbers, for example a 55 or par 38, where the letters identify the shape and their numbers some characteristic size. National standards such as ANSI C 79.1-2002 is 14897:2000, 128, and JISC 7710:1988, 129, cover a common terminology for bulb shapes. Incandescent light bulbs come in a range of shapes and sizes. Examples description such details standard light bulb A60E26 and 19E2660 mm, -19 8 in, a series bulb. 26 mm Edison screw candle flame bulb CA35E12 CA11E1235 mm, -11 8 in, candle flame shape. 12 mm Edison screw floodlight BR95E26 BR30E2695 mm, -30 8 in, floodlight. 26 mm Edison screw halogen track light bulb MR50 GU5.3 Mr 16 GU5.350 mm, -16 8 in, multifaceted reflector. 5.33 mm spaced 12V bi-pin connector. Common shape codes. General service light emitted in nearly all directions. Available either clear or frosted. Types. General, A, mushroom, elliptical, E, sine, S, tubular, T, 120V sizes, A 17, 19 and 21,230V sizes, A 55 and 60, C, high wattage general service lamps greater than 200 watts. Types, pear-shaped, PS, decorative lamps used in chandeliers, etc. Smaller candle-sized bulbs may use a smaller socket. Types, candle, B, twisted candle, bent-tip candle, CA and BA, flame, F, globe, G, lantern chimney, H, fancy round, P, 230V sizes, 45P, G95. Reflector, R, reflective coating inside the bulb directs light forward. Flood types, FL, spread light. Spot types, SP, concentrate the light. Reflector, R, bulbs put approximately double the amount half light, foot candles, on the front central area as general service, of same wattage. Types, standard reflector, R, bulged reflector, BR, elliptical reflector, crown silvered 120V sizes, R16, 20, 25 and 30,230V sizes, R50, 63, 80 and 95, C, parabolic aluminized reflector, PA, parabolic aluminized reflector, PA, bulbs control light more precisely. They produce about 4 times the concentrated light intensity of general service, and are used in recessed and track lighting. Weatherproof casings are available for outdoor spot and flood fixtures. 120V sizes, PA 16, 20, 30, 38, 56 and 64,230V sizes, PA 16, 20, 30, 38, 56 and 64 available in numerous spot and flood beam spreads. Like all light bulbs, the number represents the diameter of the bulb in 1/8 of an inch. Therefore, a PA 16 is 51 mm, 2 in diameter, a PA 20 is 64 mm, 2.5 in diameter, PA 30 is 95 mm, 3.75 in, and a PA 38 is 121 mm, 4.75 in diameter. A package of 460-watt light bulbs. Multifaceted reflector, Mr. Multifaceted reflector bulbs are usually smaller in size and run at a lower voltage, often 12V. Left to right, Mr. 16 with GU10 base, Mr. 16 with GU5.3 base, Mr. 11 with GU4 or GZ4 base. HIR/IRCHIR is a GE designation for a lamp with an infrared reflective coating. Since less heat escapes, filament burns hotter and more efficiently. 130. The OSRAM designation for a similar coating is IRC. 131. Lamp bases. Large lamps may have a screw base or a bayonet base, with one or more contacts on the base. The shell may serve as an electrical contact or only as a mechanical support. Bayonet base lamps are frequently used in automotive lamps to resist loosening by vibration. Some tubular lamps have an electrical contact at either end. Miniature lamps may have a wedge base and wire contacts, and some automotive and special purpose lamps have screw terminals for connection to wires. Very small lamps may have filament support wires extended through the base of the lamp for connections. A bipin base is often used for halogen or reflector lamps. 132. In the late 19th century, manufacturers introduced a multitude of incompatible lamp bases. General Electric's Mazda standard base sizes were soon adopted across the US. Lamp bases may be secured to the bulb with a cement, or by mechanical crimping to indentations molded into the glass bulb. Lamps intended for use in optical systems have bases with alignment features so that the filament is positioned accurately within the optical system. A screw base lamp may have a random orientation of filament when the lamp is installed in the socket. 40-watt light bulbs with standard E10, E14 and E27 Edison screw base. The double contact bayonet cap on an incandescent bulb contacts in the light bulb socket allow the electric current to pass through the base to the filament. The socket provides electrical connections and mechanical support, and allows changing the lamp when it burns out. Light output and lifetime. Incandescent lamps are very sensitive to changes in the supply voltage. These characteristics are of great practical and economic importance. For a supply voltage be near the rated voltage of the lamp, light output is approximately proportional to version 3.4. Power consumption is approximately proportional to version 1.6. Lifetime is approximately proportional to V16. Color temperature is approximately proportional to V0.42, 109. A 5% reduction in voltage will double the life of the bulb, but reduce its light output by about 16%. Long-life bulbs take advantage of this trade-off in applications such as traffic signal lamps. Since electric energy they use costs more than the cost of the bulb, general service lamps emphasize efficiency over long operating life. The objective is to minimize the cost of light, not the cost of lamps. 70. Early bulbs had a life of up to 2,500 hours, but in 1924 the Swiss cartel agreed to limit life to 1,000 hours. 133. When this was exposed in 1953, General Electric and other leading American manufacturers were banned from limiting the life. 134. The relationships above are valid for only a few percent change of voltage around standard rated conditions, but they indicate that a lamp operated at low voltage could last much longer than at rated voltage, albeit with greatly reduced light output. The Centennial light is a light bulb that is accepted with Guinness Book of World Records as having been burning almost continuously at a fire station in Livermore, California, since 1901. However, the bulb emits the equivalent light of a 4-watt bulb. A similar story can be told of a 40-watt bulb in Texas that has been illuminated since the 21st of September, 1908. It once resided in an opera house where notable celebrities stopped to take in its glow, and was moved to an area museum in 1977. 135. Photo flood lamps used for photographic lighting favor light output over life, with some lasting only 2 hours. The upper temperature limit for the filament is the melting point of the metal. Tungsten is the metal with the highest melting point, 3,695 K, 3,422 degrees Celsius, 6,191 degrees Fahrenheit. A 50-hour life projection bulb, for instance, I designed to operate only 50 degrees Celsius, 122 degrees Fahrenheit, below that melting point. Such a lamp may achieve up to 22 lumens per watt, compared with 17.5 for a 750-hour general service lamp. 70 lamps of the same power rating but designed for different voltages have different luminous efficacy. For example, a 100-watt, 1000-hour, 120-volt lamp will produce about 17.1 lumens per watt. A similar lamp designed for 230V would produce only around 12.8 lumens per watt, and one designed for 30V